Hi learners, welcome back to DHILK. In this video we are going to discuss about one of the most important organic chemistry topic, organic nomenclature, naming of organic compounds. And at the end of this session I am sure that you will be able to name any type of organic compounds with full confidence, and don't skip any part of this video. Each and every point is important, and if you need the materials you can just comment below. I will give you the complete guide for naming the organic compounds. This topic is extremely important because before you can understand reactions, mechanisms or advanced chemistry, you must first learn how to read and speak the language of organic molecules. Think of this as learning the alphabet before writing sentences. So don't skip any part. We can learn together, and I will teach you the exact way that you want to learn the naming of organic compound in a simple but powerful method. The first thing that you have to know is that there are two naming systems in organic chemistry. The first is IUPAC system, okay, and second one is common naming system. The major difference between IUPAC system and common system is that IUPAC system is the official scientific globally accepted naming method, while the common system is historical names that are still used in textbooks, daily chemistry and exams. Okay, to be strong in organic chemistry you must be comfortable with both. So we will be discussing the nomenclature or the naming of the compounds in these two ways. So first we can start with IUPAC naming system, and IUPAC stands for International Union of Pure and Applied Chemistry. And IUPAC naming is systematic and rule based. That means every compound has one unique name based on its structure. Scientists across the world use this same system so that there is no confusion about what compounds we are talking about. And you can see the general formula here: prefix plus word root plus primary suffix plus secondary suffix. That is the general structure or general formula for the naming of organic compounds. And now we can look each of these terms and get thorough with each. First we can start with word root. Okay, word root is nothing but carbon chain count, and you know organic compounds hydrocarbons includes carbon atom and hydrogen atom. So to include the number of carbon atoms in a chain in an organic compound we use some names. Okay, so word root tells us the number of carbons in the longest chain. Students often worry about memorizing these names, so there is a memory trick that we will use. And for each of the carbon atoms we have a special name. If the number of carbon atom is 1, we will use meth. If it is 2, it is eth. If it is 3, it is prop. If it is 4, it is but, pent, hex, hept, oct, non, dec. So I have given up to 10. That is important at the beginner level. For just to memorize these terms, we can use a symbol tricks. Like for this first, monkey eats peanut butter stands for the first 4. Penny has huge. Penny for pent, has for hex, huge for hept. And octopus nose drawings. Octopus nose drawings. So this way, you can just use this trick to memorize these names. So what are the different word roots for based on the number of carbon atoms? Meth, eth, prop, but, pent, hex, hept, oct, non, dec. Okay, and from C1 to C4 we have historical roots, but from C5 onwards we are using some Greek or Latin prefixes, and that's just symbol. Just to get the point I just mentioned here. So this is word root. Now we can move to primary suffix, means degree of saturation. That means in hydrocarbons, in organic compounds, there may be single bond, double bond or triple bond between carbon atoms. So based on that we will mention the degree of saturation in the compound. Suffix means the end of the name. Okay, what we will add at the end of the name. So if all the carbon-carbon bonds are single bonds, we will name it will end with "ane". Suffix is "ane". For example, we can take a organic compound which has 3 carbon atom. If the 3 carbon atom is there, then the compound is word root is prop, right? So if it is prop, then it will end with the suffix "ane". Now the name of the compound is propane. Okay. And if there is a carbon-carbon double bond between 2 carbon atoms, then the suffix is "ene". Okay, it is "ene". So instead of "ane", the same compound which has number of carbon atom 3, instead of propane it will be propene. Got it? And again we can move to, if there is a triple bond between carbon atoms, then it will end with yne, Y-N-E, yne. And the same compound, we can look at this compound, the same compound, instead of propane it will be propyne. We will go through each and every examples with the structures, don't worry about this. I mean, just now for the timing you have to understand the suffix name only. Now we are clear with word root, right? Now we are discussing about the suffix, so you have to be clear about the suffix. If there is only a carbon-carbon single bond, it is ane, double bond, ene, triple bond, yne. Okay. Now, if two carbon-carbon double bonds are there, what we will use? What we will use? So, we will use a diene. Di stands for two. Ene. Ene is for carbon-carbon double bond, suffix is ene. So, if there are two carbon-carbon double bonds, we will use a diene. For example, buta-1,3-diene. Okay, buta-1,3-diene. So but stands for 4 hydrocarbons with 4 carbon atoms. Okay, but. And after that we have to mention this, you don't have to worry about this. After that we will discuss it later. As a suffix we will use diene. Okay, diene means 2 double bonds. Next is that if there is carbon-carbon double bond and triple bond, both comes together, what we will use? If double bond and triple bond comes together, we have to use ene, yne in together. Ene for double bond, yne for triple bond. We have to use both in together. And for example, we can look at this. Pen is a hydrocarbon which has 5 number of carbon atoms, and if there is double and triple bonds comes together, we will use pent, ene, yne. Ene, yne. This represents the double bond and triple bond come in the same compound. Okay, don't worry about these numbers, we will discuss in detail. Okay, next is that functional group priority. Now if there are functional group means, so think of it like this: the functional group is the active part of a compound, the part that actually reacts and gives the compound its identity. Means even if two compounds has similar carbon chains, and different functional groups will give different behavior, like that. Now we can look at the examples. So there are, look at this functional group carboxylic acid, which has the formula COOH, and that has suffix oic acid. Okay, oic acid. It will end, the compound will end with oic acid. And sulfonic acid, the suffix is sulfonic acid itself. I mean, that is same, and the formula is SO3H. If it is acid anhydride, which has the formula CO twice O. Twice O means there are 2 CO groups, and at the center there will be an oxygen atom. Its suffix is oic anhydrate. Oic anhydrate. And next is esters. Esters are the compounds which has the group COOR. COOR. R can be any type of hydrocarbon that has the suffix oate. If it is methane, methanoate, ethane, ethanoate. Okay, like that. Then if it is acid halide, it will end with oil halide. Maybe it may be a little bit confusing right now with these suffix names, but later it will be clear for you once we come with the examples. Okay, then if the functional group is amide, it will end with amide itself. And that's about the suffix of some of these functional groups. The rest we are discussing in the next slide. And we have to know about prefix also. Prefix means it is a part of the compound's name that appears before the root word. Root word. We have this general formula: prefix plus word root plus primary suffix plus secondary suffix. Means that word root we know the number of carbon atoms, right? And prefix will come before the word root, while suffix will come after the word root. Okay, and suffix can be primary and secondary. We will discuss that. First you have to understand word root is number of carbon atoms, and prefix will come before the word root, and suffix will come after the word root. Okay, so now if the functional group has to come as a prefix, we will use the corresponding, for each corresponding carboxylic acid, for each corresponding functional group that has a specific prefix. For carboxylic acid, the prefix is carboxy. Sulfonic acid, sulfur. For acid anhydride, there is no prefix name. For esters, alkoxycarbonyl. Don't be confused, I am repeating again. Don't be confused or tensed right now. We will get this later. These names. First you have to understand that there is different terms called suffix, prefix and word roots. Okay. Now, only the highest priority group gets suffix. All others become prefix. What does it mean? It means that during the naming of the compounds, maybe some functional groups repeats. Maybe in a single compound there will be multiple functional groups. Okay, there are multiple complications that comes during the naming of the systems, but we will discuss. We will make everything clear. But you can keep this point in mind. Only the highest priority group gets a suffix. All others will become prefix. Okay. Now there are some other functional groups. We had discussed 6 functional groups in this slide. Here there are some. We are discussing other 6 functional groups. Nitriles. Nitriles means the organic compounds which has carbon triple bond N bond. For such compounds, we will use nitrile as the suffix, and the prefix will be cyano. Nitriles. For nitriles, the prefix is cyano, suffix is nitrile. And for aldehydes, which has the formula CHO, the suffix is al. The compound will end with al. Prefix is formyl or oxo. Ketone. For ketone, if the functional group is ketone, its suffix is on. The compound will end with on. Or if it is used as prefix, it will be having the name oxo. Okay. And alcohols, it is ol. Prefix is hydroxy. For thiols, thiols is nothing but instead of CH, it will be SH. Suffix is thiol itself and prefix will be mercapto. Prefix is mercapto. And for amines, the second functional group which has nitrogen atom, one is nitrile, another one is amine. For amines, the suffix is amine itself and prefix will be amino. Amine, amino. And ether and halogen, there are some other functional groups like ethers and halogen. For ethers, it never gets suffix, always prefix only. And one thing that you have to note down is that ether and halogen, these are some other functional groups, ether and halogen, they never get suffix. Okay, they always used as prefixes. They will never get suffixes. Like that, like alkoxy. Like ethers will always be having the prefix as alkoxy. And for halogens, we will use fluoro, chloro, bromo, iodo based on the corresponding halogen. For example, if the halogen atom is fluorine, the suffix will be fluoro. For if it is chlorine, the suffix will be chloro. Like that. Okay, got it? So we covered the portions. What is word root? What is suffix, what is prefix, and what are the different suffix and prefixes that we can use for different functional groups. Clear? Now we are moving to IUPAC naming 5-step algorithm. This is our naming algorithm. Whatever we had learned up to now is basics of nomenclature. Now we are moving to IUPAC naming. So there are 5 steps to name a compound. And we will discuss these steps and details in the next video, because otherwise this video will be long. So we are winding up here. So like, subscribe and turn on the notifications to get more videos.